Welcome to another video. Today we're looking at the IEB May 2023 paper 1 question 9. Let's get into it. So a golf ball is hit from point A to point B, right? Very kindly provided us with a diagram. That's awesome. So we've got a dude who is chilling on a cliff and he hits a golf ball from point A and it goes all the way until it lands at point B, right? And it's giving parabola. But let's see. Let's not jump ahead too far. Point A is 30 meters vertically above the ground, okay? Point B is 300 meters away from A on ground level. So the horizontal distance between A and B is 300 meters. Nice. The path of the golf ball is modeled by y is equal to ax squared plus bx plus c. Parabola, right? A quadratic function. Nice. The ball passes through the point 230, right? So what does that information mean in the context of this problem, right? So we are... Okay, let me not jump ahead, right? Let's see what this next statement says. I was already going to do some assumptions, but this next statement actually saves me from having to assume. The path of the flight of the golf ball is placed in the Cartesian plane so that A is on the y-axis and B is on the x-axis, right? So let's get our ruler out just to make it abundantly clear, right? So we are saying that this is our x-axis. Let's do a vivacious color. All right, so we're saying that this is our x-axis, and over there this is our this is our y-axis. Okay, that's too enthusiastic of a y-axis, man. Right, so y-axis goes through A and x-axis goes through point B. Okay, and furthermore, it's also important to think about, okay, what does x represent and what does y represent? So x is representing the distance of the ball, the horizontal distance of the ball from point A, okay? And y is representing the height of the ball above the ground. So it's very important to remember or have an idea of what these variables mean, because that will also then enable you to think about, well, what does this statement mean, right? So we're being told that when x is equal to 200, y is equal to 30. So in the context of this problem, what that means is when the ball is 200 meters away from point A horizontally, its height above the ground is 30 meters. Very important. So we have this point here. Maybe let's get my ruler again. Okay. And it's very cool that, and it's not coincidental, that the height of the ball above the ground is 30 meters. That's also going to be very useful to us. Right, so we're being told that the first time that the ball is 30 meters above the ground is when at point A, so when it's 0 meters away from point A. But the second time that it is 30 meters above the ground is when it is 200 meters away from so this is 200 meters away from A. Where are my words? Right, maybe let's get back to more visible colors. So this is the point 230. Right, and the question asks us to determine the maximum height that the ball reaches above the ground. So essentially, we need to figure out the y-coordinate of the turning point, right? The turning point is where it hits its highest point above the ground. Okay, and the reason why I got so excited when I saw that we have the point 230 is because I thought about the fact that a parabola is a symmetric shape, right? And the turning point goes through the axis of symmetry. So when we think about a parabola, right, it has an axis of symmetry, which is pretty much the line that you can fold the parabola over, and the one half of it will fit perfectly over the other half, right? So the importance of this is that if, for example, you know that for whatever parabola we have a point 5,2, and this is some other point 1,2, right? These guys are on the same horizontal line, right? And because of the symmetry, we then know that this distance from the axis of symmetry is the same as this distance from the axis of symmetry, right? And because the distance from 1,2 to 5,2 is 4, that means that this distance is 2 units and this distance is also 2 units, which means that we might not know what the y-coordinate of the turning point is, but it is equidistant from, the x-coordinate is equidistant from 1 and 5, right? It's directly halfway between 1 and 5. So the x-coordinate would be 3 and some other number that we'd have to figure out. So we can use this logic in this case as well, right? Where we have my missing ruler. Okay, right? So let's say our turning point is somewhere over there. Okay. Right, then we know that its x-coordinate is directly halfway between the x-coordinate of A, which is 0, and the x-coordinate of this guy, which is 200, because they're on the same horizontal line. And so what is halfway between 0 and 200? Well, it is 100, right? So you either just know that intuitively, or you could just find the average between 0 and 200. 0 plus 200 divided by 2, which would give you 100. So we now know that the turning point happens when the ball is 100 meters away from point A. Now we need to figure out, well, what is the height of the ball at that point? What is the y-coordinate for this x-coordinate? And we get that by putting the x into this equation, the equation for the parabola, right? That will give us the y. However, we do not know a, b, and c, right? Which are the, what would you call it? The parameters of the quadratic function. I don't know if we call it that. But yeah, essentially we need to figure out a, b, and c in order for us to be able to conclude this calculation. So how do we figure out a, b, and c? Well, we need to get 3 points, right? 3 unknowns, A, B, C, means we need 3 bits of information in order to figure out what they are. If you had 5 unknowns, then you would need 5 bits of information in order to figure out what the unknowns are. And yeah, okay, so what do we know? We know that when x is 0, y is equal to 30. We also know that when x is 200, y is equal to 30. Okay, then another kind of point that's lurking is b, right? When x is equal to 300, y is equal to 0. The ball is not above the ground anymore, it's on the ground. So there's no height above the ground, the height is 0. So there are our 3 bits of information that we can use to figure out what A, B, and C are. So let us do that, right? So let's start with the nicest point, right? Which is when x is 0. And it's nice because if we sub that point in, maybe let's do that here. Oh, writing with highlighter. When x is 0, okay, we have y, well, y is equal to 30. So what that means is 30 is equal to a times 0 squared plus b times 0 plus c, right? And the nice thing is that this term is going to disappear. Anything times 0 just becomes 0. And likewise, this term is also going to disappear. So what that leaves us with is that C is equal to 30. Okay, now I'm just going to take this and move it on to the next page, right? Can I cut this? Oh, it cut everything. Don't cut everything. Right, let's try that again. What? Yeah, it's more like it. Right, so let's paste that. How do I paste it? It's gone. I cut it and it will not be pastable. How did I get that menu last time? Oh, there we go. Yay, the wonders of science. Right, so back up we go. Right, so we now know that C is equal to 30. We're going to just hold on to this in the corner over here. Right, so next point we have is 230. Right, so when X is equal to 200, we know that Y is equal to 30. Right, so let's sub that into our function. So we have Y is equal to A times X squared plus B times X plus C, which we have found to be 30. Right, and we see that, okay, there's a 30 on both sides here, so we can subtract 30 from both sides, and then we're just left with 0 is equal to 40,000 A plus 200 B, right? And what we can do here, just to make our equation a bit nicer, we can divide both sides by 200, right? So that we're not working with these very, very big numbers. So 0 divided by 200. Did I say 200 or 2,000? I meant 200. Anyway, right. And 40,000 divided by 200 will just take us back to 200. And then over here we will have B, right? So we now have an equation with two unknowns, okay? And that should be now hinting at simultaneous equations, right? So we're going to get another equation, maybe just in terms of A, maybe just in terms of B, maybe in terms of both, and we'll solve the system of equations simultaneously, right? So let's hold on to this as our equation number 1. So let me move this. No. Let me duplicate it rather. Where did it duplicate it? The mysteries. Oh, it duplicated it below. Nice. Okay, so that's very sweet of them, hey? To do it out of the way. I was a bit worried. Okay, so we know that this is going to be our first equation in our system of equations. And let's move this down. Oh! I must be like a goldfish. Like in a previous life, I must have been a goldfish, honestly. Because how do I just keep making the same mistakes? Bizarre. Okay, so now we're going to paste. Maybe I should stop trying to select. Sorry, thinking out loud. Well, I mean, that's kind of the point of this channel, but some things I shouldn't really think out loud. Right, so that's our first equation, perfect. Then our second equation we're going to get from, maybe let's get rid of this guy. We're going to get from our last point, right? So when X is equal to 300, we know that Y is equal to 0, right? So let's sub that into the quadratic function there. So we have Y is equal to 0, A times X squared plus B times X plus C, which we know is 30. Right, so we've got 0 is equal to 9, 0, 0, 0, 0, A plus 300B plus 30. Okay, so that's our second equation potentially, but let's just make it a bit nicer. So a nice common factor that we can divide by, just to make our numbers a bit smaller, is 30. So 0 divided by 30 is just 0. And 90,000 divided by 30 will be 3,000 A. This one will become 10 B. And this one will become 1. Right? And then just so that this equation can look something like this one, right? I'm going to minus 1 on both sides so that we have something A plus something B is equal to some number. So let's say we're going to, change of colors. Minus 1 on both sides, right? And that will give us minus 1 is equal to 3,000 A plus 10 B. And that then becomes our second equation, right? So I'm just going to duplicate this one and shrink it and move it. Perfect. Then let's move these guys down. I hope that gets everything. Oui. Right. Okay, so these are now our two equations. Let's bring them back to this, to the center. You know, I could try to test how good my freeform selection is. Not bad. Right, so we have 0 is equal to 200A plus B, and our second equation is negative 1 is equal to 3000A plus 10B. And simultaneous equations, there's at least two ways that you can solve, right? You could use the process of elimination, or you could use the process of substitution. I am always a fan of elimination, unless the coefficients are fractions or something weird like that. Maybe then I'd stay away from it. But in a situation like this, I immediately just think, okay, let's take equation number 1 and times it by 10 so that we can get 10b over here, right? And then we'll be able to eliminate it with that one. So we then have 0 times 10, which is 0. What I just did is a 0, right? 200 times 10 is 2000 A, and then b times 10 is 10b, right? So that will be just a re-expression of equation number 1. And then let's subtract equation number 2, right? So that equation, again, let's move this guy. Right, so that equation is negative 1 is equal to 3000 A plus 10B, right? So if we subtract that, what we end up with is, okay, 0 minus minus 1 is 0 plus 1, which is positive 1. 2000 minus 3000A is minus 1000A. And 10b minus 10b is 0, right? And so we get 1 is equal to minus 1000A. And if we divide both sides by negative 1,000, we get a is equal to negative 1 over 1,000, which is good, right? Always like kind of, it's easy with maths to just kind of get lost in the operations, and we are solving an equation and we kind of lose sight of what are we trying to work towards. Remember that we're trying to find the a, b, and c in this equation over here, right? So we know that when the a is negative, the parabola is a sad parabola. When it's positive, then we get a concave up parabola, right? To use the more the more technically correct terms. So because this parabola is a downward facing parabola, concave down parabola, it's good that we have gotten an a that's a negative number, right? If we had gotten an a that was positive, then we would know that calculations have gone awry somewhere, right? So let's maybe I should have said all of that while I was moving stuff down, you know. Efficiency, question mark. Okay, so let's move. Oh, what is happening? Okay, maybe let's stay away from the very bottom, right? So we now know that, oh, that's not what I want to do. I want to duplicate it. Oh, can I not? I can. And I can move it. Right, so let's, this should be easy to do with a box. Oh, yeah, let's just cut it. And, right, move it down here. Good. Okay, right. And back up we go. Okay, so we now know that a is equal to negative 1,000. Perfect. So we now need to figure out what b is, which we can figure out by putting into either of the equations, right? So sub a is equal to negative 1,000 into, let's say, the first one. So then we have 0 is equal to 200 times negative 1,000 plus b, right, which ends up being negative 1/5 plus b, right? And so then b must be equal to positive 1/5. Negative 1/5 plus positive 1/5 gives us the 0 that we want. Always a good idea to then sanity check your result, right? So if you put a and b into this equation, then you should end up with -1. If you don't, again, you know that maybe your calculations went funky somewhere, right? So let's see, 3,000 times negative 1,000, 1,000th, plus 10 times 1/5. All right, let's see what that works out to. So the first term is -3, the second term is 2, and that does indeed give us -1. Right, perfecto. So what do I want to move? I want to move this guy. First we duplicate. This is really, oh, I need to, no, I can't figure it out. Okay, maybe I'm figuring it out, who knows. Okay, let's move this, and also let's just label what's going on here. So this is sanity check. Okay, right, we can now move our stuff. Oh, new page. Right. Okay, so we now know that A is equal to negative 1,000th, B is equal to a fifth, right? So therefore, Y is equal to negative 1,000th x squared plus a fifth x plus c, which we very long ago determined to be equal to 30, right? So this guy over here. Cool. So we now have the equation for the parabola, right? The function. And remember that we needed it because we now had the x coordinate for the turning point, but we needed to figure out the y coordinate because that would give us the maximum height that the golf hits above the ground, that the golf ball reaches above the ground, not the golf. Right? So when x is equal to 100, y is equal to negative 1,000th times 100 squared plus a fifth times 100 plus 30. Right, let's get Mr. Calcs in the building. Right, so, oh, and I have to confess that I did record another video doing this problem, but I kept deleting my workings, and I had forgotten that I had made a promise that if I did arrive at the wrong answer, I would then spend some time to go look at my calculations and see where I went wrong. But because now in that video I had just been erasing my workings instead of moving them to a new page, I wasn't able to go back and trace my steps and see where I had messed up. So I just remembered when I brought out the calculator and it still had the wrong calculations from my previous workings. Anyway, so I've punched this expression in and it gives us an answer of 40. Right? So what does this tell us? This is telling us that let's just give myself time. Right, this is telling us that the golf ball, when it's 100 meters away from A, it reaches a height of 40, which is actually then the highest point that it reaches before it starts its descent to the ground. Cool.